Hi, my name is Mr. Green and I'm one of the computer scientists here at Consett Academy. I'm going to give you a brief overview into the exciting course which is A-Level Computing and hopefully answer any questions you may have about the course structure, but please feel free if you want to ask me any questions is drop me an email. Computing is all of the things that are listed there, not in any particular order, but there's a reason why programming is at the bottom of the list. So computing is around about problem solving. It's about taking problems and looking at their constituent parts to it, which is through decomposition. Abstraction is removing unnecessary detail. Think about Mario, the original Mario games. Think about a tree. A tree was basically a triangle, a green triangle with a brown stick at the bottom of it. That is the abstracted version of a tree. It's not. It is a tree. It represents a tree. It doesn't have the same characteristics as a tree all the time, but everybody knows it's a tree. So abstraction is removing unnecessary detail, and we need to understand that before we can program things. We have to look at what is the actual thing we're trying to solve. We also look at the theoretical ways to store data, to process data, and also how to develop software efficiently and effectively. And at the bottom of the list is programming. Now we program in a variety of different languages. We program in Python. We do some web development using CSS, HTML, and JavaScript. We also look at SQL for databases. So there's a variety of different programming languages that we can use. So computing is a wide-ranging subject with lots of different elements. Here are some reasons why our current computing students have took computing. The most interesting one on there for me is the computer science is extremely useful for future career paths regardless of the job. I think this is especially true, say, in biomedical sciences or in engineering, where computing is used every day to solve problems and to investigate. I was lucky enough to go to a seminar which was led by a neurologist at Newcastle University, and he said that they're using computing models to see the effect of epilepsy on the brain. This wasn't done by a separate team of computer scientists, it was done by neurologists with computing skills. It just shows this. The computer science is becoming everyday, and the need for programming and understanding how computers work is vital. The course content follows roughly on from the GCSE. This is the OCR specification. So from paper 1, it follows the same trends. So we look at the systems architecture, software development, how we exchange data, which includes web development, and we look at data types and data structures, which is stacks and queues, and we also look at the legal, moral, cultural and ethical issues. The paper 2, again, it's a problem solving paper, so we look at the elements of computational thinking to solve problems, and we look at algorithms such as searching and sorting and have to implement them, which is a step up from GCSE, where we would normally simply implement them. We actually have to be able to code them at A level. The last part of the project, or the last part of the A level, is a programming project. So in year 13, we start the A level project, and it is looking at creating a piece of software. It can be a game, it can be a data processing system, it can be anything, as long as it has a store of data and it has a graphical user interface. It's similar to the NEA that Year 11 are doing at the moment, the programming project, in the sense that you have to analyse, design, implement and evaluate a solution. The assessment structure is on the screen. A-level is 2.5 hours long, the 2 papers of the programming project with 20%. The AS doesn't have the programming project. It has 2 papers of 1 hour and 15 minutes each. So we have some requirements for the course, but GCSE computing is not essential. We've had many successful students who have not done GCSE computing and gone on to do A-level. There is a little bit of a step up, and there's some programming elements that you need to learn, but the course content we do make sure that we go over from the ability in the class. An interest in computing and how things work is essential. Wanting to know how things are developed and put together and being able to actually have an interest in technology is extremely important. Remember, this is not a programming course. This is thinking about problem solving and computational thinking. Two different things. If you're not the best programmer in the world and you still enjoy competing, this course is still for you. If you want to do a programming course and not want to think about everything else, this course isn't for you. We've had a number of successful students studying with us in computer science. Kieran became an apprentice systems engineer in a company down in Gloucester, so he moved down there. One of a lot of applicants got down to the interview stages and then got one of the 11 apprentices in a really exciting field. We have a number of students who have moved to go to university, local universities as well as further afield, and again here's just a few who have gone on to study computing. There's some really exciting fields within computing, such as James, who's studying forensic computing. I know that he's now in his second or third year, and he had a really exciting work placement working for a bank looking at the cybersecurity. So there's some really exciting opportunities that can come from computing with some great job prospects. So if you do have any questions about computing, please give me an email at jgreen@concettacademy.org.uk. Be it entry requirements or a bit more detail about what the course we offer or how we structure the course, and please feel free to drop me an email. Just to sum up, I do find computing really exciting. I know I am a computer scientist and I'm a bit biased, but I do really enjoy the subject, enjoy learning new things, pushing my programming, trying to make different things happen. For me, the programming constructs and the theory behind it doesn't really change from year to year, but the tools that we use do, and that's why it's really important in this course that we do discuss the theoretical concepts and how things work rather than simply programming. Please feel free to let me know if you've got any questions. I look forward to being in touch with you.